way over there, all the way. All right, Michael, get over here. No, when we're done and after Yumi comes back, then you are more than welcome to go get water. Okay?
I'm opening up the pen.
Oh. Wait. No, let me do the demonstration first.
Okay.
No, because it's going to make too much noise and my throat already hurts from talking about, okay? All right, you stand over there. Okay, now I want the three of you to line up with this row of squares here so that you're directly in front of each other and you're going to face each other. So you can face, so you two are facing inward and then you get to choose whoever you want to face, okay? All right, okay, so they're all three of them are lined up, right? Lyra, Orion, the sun.
Why can't I get Orion?
Okay, fine. Orion, Lyra, the sun, and Earth. All right? Okay, now.
Maybe I want to be Earth.
I have to because I know what I'm going to say next. So maybe where I'm going to
tell me in my ear.
Girls, no. All right.
I like that.
You're the harp, you're the hunter, you're the sun, I'm the earth. I'm Mother Earth. I'm Mother Earth.
What am I?
You're the harp.
What is the harp?
Lyra. You're the beautiful Lyra. Yeah.
They don't look like it.
Could you hurry up? Shh.
Don't shush me.
Okay. All right. So we have Orion the hunter. There's the sun, and I'm the earth. In the sun's orbit in the Earth's orbit around the sun, in the winter time, okay, here on Earth, we have the view of Orion. So I can see Orion in the winter, but I cannot see Lyra because the sun is blocking Lyra, okay? In the fall, in the spring, I can see both of them. But in the winter, I can only see Orion. I cannot see Lyra. And then in the summertime, okay, I cannot see Orion, but I can see Lyra. So now Lyra is visible to me in the summertime, but Orion is being blocked because the sun is in the winter. So you guys understand?
So you go around getting everyone?
Huh?
You go around getting everything?
Yeah, so the Earth, because the Earth is traveling around the sun, at different points of the year, we have different views of the night sky. So in the fall and the spring, we can see both of these constellations, right? But in the summer or the winter, one of them is blocked off because the sun is in the way. Just like in the fall and the spring, there are other constellations that become invisible because the sun is blocking.
I think this would be better if I get more space.
I know, but
Yeah,
what are we gonna do? All right, thank you. You go get your water. You wait in line for your water. Okay.
I gotta wait. Then which make me stand up?
You got your water. I got my Monster.
We've talked about this whole monster thing, okay?
I got 173 bottle caps of it.
Guys, that's bad for you. It's going to cause you to have a heart attack. It's going to mess up your heart and your insides.
I stopped drinking water.
And the liver.
Like beginning of the year, and I stopped drinking soda like 2 months ago.
Do you know how much sugar are in those drinks? And when you compare them, like, okay, what, there's about that much sugar in the soda. There's about that much sugar in the Monster. Like, it's almost a can full of sugar.
Wait, let me see how
Which
many.
is not good for you, especially that sugar that's processed. It's not natural, so there are different chemical reactions that are occurring in your body. Like, it's just not good all around for your whole metabolic system. All right.
Sugar in this one is 81 grams.
That's you're not supposed to be drinking it. Put
The
it
regular
away.
size is 27.
Here, I'll hold it for you. I'll hold it for you. Oh no, I'm not gonna drink it. The sink might drink it though.
Oh, she's trying to throw it away. You know that costs $2 right there?
Oh my goodness.
No, this cost me like $3.15.
So I'll buy him a gallon of water and it'll be fine. All right. So these are what those two constellations I was just talking about. This is what they look like in the night sky. So Lyra is the harp, so it's a little dipper, and then little or big dipper. I don't remember. I'm a bad science teacher. And then you have Orion. Okay, Orion is the hunter, and the easy way to find them is to look for those three stars. So with Lyra, it's that brightest star right there that will help you to locate it. But with Orion, 1, 2, 3, there are 3 stars in a row, and that makes up Orion's belt. Okay. Now, when we look at these stars, when we look in the night sky, some of the stars look brighter than others to us. Just us making that observation, oh, the star on the right is brighter than the star on the left, that is called apparent magnitude. So apparent magnitude is how bright the star appears to be to an observer here on Earth. So the star on the right looks brighter than the star on the left. That doesn't mean that the star on the right really is brighter than the star on the left. It just means that that's what it looks like to us. For all we know, the star on the left is actually brighter and it's just farther away. The good example, which they love to use a lot in a lot of these science videos, is that if you see a train coming down a tunnel, okay, you walk behind the desk so it's not disrespecting me, okay? Thank you. So when a train when a train is coming down the tunnel, right? When it's farthest away from you, the light on the front of the train looks dim. But as it gets closer to you, the light looks brighter, bigger and brighter, because it's getting closer to you. It's the same light from close up or far away. It's the same light pushing out the same wattage. But because it's at a different distance, it appears different to you. So that's apparent magnitude. Some stars look dimmer because those dimmer stars are further away and those brighter stars are closer. Okay? So that's apparent magnitude. Now, if we're going to now try to figure out how far these stars are away from us and really determine what their actual brightness is, their actual brightness is known as the absolute magnitude. Like, remember relative and absolute dating? Absolute dating was the actual number of how old the rock was. Okay? So absolute magnitude is a true measure of its brightness. So magnitude is referring to how bright the star is, that word magnitude. All right? But if we're going to know that, we first have to measure. And if we're going to measure in space, we have to come up with new units of measurement. So there are 3 basic units of measurements when you measure in space. Because any measurement that we would use here on Earth is not large enough.
Excuse interruption, Ms. Castro-Reeves. Please contact extension 54907. Ms. Castro-Reeves, extension 54907.
Space is so vast, it's so big that it's so unimaginably large in comparison to anything that we're used to here on this planet. So measuring from here to another galaxy even would be like trying to measure from Chicago to LA using not even millimeters but like micrometers, okay? Like I'm gonna measure distance using micrometers from here to LA. It doesn't make any sense, right? It's gonna be a ridiculous number and we're gonna be like, what the hell does that mean? I don't know. Alright? So we'll take the units of measurement that we know here, largest units, which would be like a kilometer, right? And we're going to make new measurements out of that to give us a better understanding of how vast the distance really is. So the first unit of measurement is called an astronomical unit, and we abbreviate it capital A, capital U, AU, astronomical unit. 1 astronomical unit is the distance between the Earth and the Sun. And we're going to see over and over again that when we're measuring in space, we're going to use what we already know. We already know how far the distance is from our Earth to our Sun, and because we're here on the Earth, we want to know, well, how far away is it? And we compare, and we always think back to something here on the planet. So that's the measurement that we use. So the distance between our Earth to the Sun is 150 million kilometers. So 1 astronomical unit is equal to 150 million kilometers. And astronomical units are best used, so this is the smallest unit of measurement in space, and it's best used to measure within the solar system. Now this last sentence here is not on your notes, so find this slide and copy that last sentence down. And the next 2 slides are going to do the same. You're going to copy the last sentence, okay? I added it later, and I forgot to print it, sorry. We'll see you time. Okay?
I'm gonna drink that can after this class.
So, an astronomical unit, the smallest unit of space measurement, is used to measure the distance within the solar system. So if I want to know how far away Earth and Mercury are from each other, or Venus and Neptune, or Venus and the Kuiper belt, or Mars and the asteroid belt, I'm going to use an astronomical unit to measure that. Okay? And that's still vast distances. It's still a really large distance, and that's only us within our own little solar system. Okay? I forgot to upload. I was going to upload a picture and put it on here, but then I don't get access to Facebook, and I forgot my little string to tether it to the computer. I had a really nice picture I saw on Facebook that
Can you add me?
after you graduate, Ms. Guzman can be kind of
Patient.
herself on Facebook.
I don't
Okay?
care if I can come go around telling everybody.
Damn kids, blah blah blah. Ruin my day.
I'm a favorite.
No, I don't complain like that. Usually it's just pictures of my kids and stuff like that,
I
or
wanna see
political
your
quotes
kids.
and whatnot.
I want to see your kids.
Only once in a great while will it be something personal, and it's usually like, da, 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 this.
What if I transfer?
Sure,
I'm
transfer
gonna
again.
transfer next year.
Okay.
Well, this year.
Okay. All right. The last slide. Copy this last slide onto the next one. Okay. The second unit of measurement is a light year, and the light year is basically the overall unit of measurement that you're going to see measured in space. It's used to measure the distances between stars and the distances between galaxies. So if I wanted to know how far away our sun is from the next sun over, which is Proxima Centauri, then I would use a light year to measure that. Or if I wanted to know how far, how much space is in between our galaxy, the Milky Way galaxy, and the Andromeda galaxy, which is our neighboring galaxy, I would use a light year or a parsec. Okay. So it says that a light year measures the distance that a ray of light can travel in 1 year. So how fast can light travel in 1 year? So things that are traveling at the speed of light, we call it a light year. And the amount of distance that light can travel in 1 year is 9.5 trillion kilometers. 9.5 trillion kilometers. That's a really large number. So the next star over Proxima Centauri is 4.2 light years away from Earth. So that's like saying 4.2 times 9.5 trillion. That's how much? That's almost.
19 trillion.
Huh?
19.
No, 9.5 times 4.2 is what?
Oh,
40 what?
40.
Almost 50. So we'll say almost 50 trillion kilometers. So instead of saying 50 or 46.852, whatever it is, trillion kilometers, we will just say 4.2 light years. And so you understand that that's how big the distance is. Do you see what I'm saying? When you use such large numbers like that, you kind of lose track of how far away it really is. So we break it down into these smaller units of measurement. Okay? So that light year, you're going to see that a lot of these things are measured in light years. All right?